WhatsApp once pushed an update that broke messaging for 2 billion users, and the culprit was data encoding. Now, here's what went wrong. Imagine this. You're a backend engineer on WhatsApp and you add a new field to the user's profile. It seems harmless, right? You deploy the code and suddenly 2 billion users can't send the message. Old app version crashes and there is chaos. Now, this isn't fiction. This is what happens when you don't understand data encoding and schema evolution. Every time Netflix adds a feature, Uber updates their app, or Google rolls out any changes, they are dealing with the same problem. How do you evolve your data format without breaking the existing systems? Now, today we are going to deep dive into data encoding and evolution in distributed systems. But then you will understand why this is the most important and underrated topic in system design interviews and how to nail the questions about it. So let's get started. Data encoding is the translation layer between different systems. Think of it like this: you're speaking English and your friend speaks Spanish. You need a translator. So in distributed system, the encoding is the translator. Now here's the problem. In memory, your data is objects, classes, structs, or pointers. But when you send the data over the network or save it to disk, you need bytes. Just raw bytes. This conversion has two directions. First is encoding, and then second is decoding. Encoding or serialization. This is in-memory object conversion to the byte sequence. Decoding or deserialization is byte sequence converted to in-memory object. Now, why does this matter? Here are three reasons. First is efficiency. The smaller the encoding, faster network transfer, and then lower cost. Compatibility. Old code must be able to read the new data. Similarly, when a new code is deployed, it must be able to read the old data. And the third is evolution. Your schema will keep on changing and evolving. Can your system handle it? Let me take a real world example. So when you send a message on Slack, it's encoded in JSON format and sent over HTTP. Then it is decoded by the server, re-encoded for the database, and decoded again when your friend receives it. 4 encoding and decoding cycles for just one message. This is why fan companies obsess over the encoding formats. Now, every programming language has a built-in serialization. Java has a serializable, Python has pickle, Ruby has Marshall. They're convenient. They're also terrible for distributed systems. Let me show you why. Language-specific formats has its own fatal flaws. Problem one is the language lock-in. Your Java service can't talk to a Python service. You're stuck in one ecosystem. Problem two is security risk. Deserializing untrusted data can execute any arbitrary code. Now, this is how the major hacks happen. Problem three is versioning nightmare. If you add a field and then old code breaks, if you remove a field, then the new code breaks. It is not either backward compatible or forward compatible. We have to maintain them. Now, problem four is performance. Java serialization is very slow. It includes full class names, type info, everything, and massive overhead. Now, here's a real world example. Twitter migrated away from Java serialization to Thrift. And the result is 5x smaller messages, 3x faster serialization. For interview, if someone suggests language specific formats in a specific system design interview, it's a red flag. Always use language agnostic formats. So let's compare some of the commonly used variants. Here we talk about JSON, XML, and other binary formats. JSON is everywhere. It's also wasting 80% of your bandwidth. Now, here's the alternative that Netflix uses. Let's talk about first JSON and XML because both are very verbose language. We'll talk. JSON stands for JavaScript Object Notation. It is human readable, language agnostic, and widely supported. But the huge problem is it is text based. You use user ID, name, age, and then specify the values. Each of the field names, for each value, you annotate it with a field name. For example, user ID is equal to 1234. Name, you can write Alice, age 30. Every time when you send a message, you have to specify the key and the value. This is a massive waste of space. XML is even worse, more verbose, harder to parse, and slower. There enters the binary variants, which are much more compact and much more faster. The first one we can talk about MessagePack. It is JSON but binary. Same structure but 50% smaller. BSON, that is binary JSON used by MongoDB. It adds type info. CBOR, concise binary object representation, smaller than MessagePack. Now here's the comparison chart of the differences between the JSON format and the binary format. In each of them, the user profile, the product catalog, or the log entry, or the sensor data, you see 65% difference, round about that. So the difference in the sizes is 65% in the user profile. If the JSON format is using 245 bytes, the similar binary variants use 87 bytes. So you see the difference is way more smaller and compact, much more faster. Now at Netflix scale, billions of requests happens, and this saves millions in bandwidth cost. But there's a catch. Binary formats aren't human readable. You need tools to inspect them. So the trade-off is efficiency versus debuggability. In interview, someone asks you, when would you use JSON or binary format? You should answer like this. JSON for public APIs so that we can debug it. Binary for internal services because we want efficiency, we want faster. Now, protocol buffers and thrift are the gold standard for encoding at scale. Now, Google uses Protobuf for all internal services. Facebook created thrift for the same reason. These aren't just encoding format, they are complete systems for schema evolution. Let me break down them for you. Now, how protocol buffer works. First, we define the schema. In the schema, if you see, I have mentioned the type string name, then type int32 as age, then type string as email. Each one of them has a tag. Name is tagged to 1, age is tagged to 2, and email is tagged to 3. This is just like a primary key. You have put a tag. These numbers are called field tags. If you see, they are mapped to the field tag values in the binary format. Then we have done the schema definition, we generate the code. The Protobuf compiler generates classes in any language. It can be in Java, Python, Go, or C++. After generating the code, we encode it. Step 3 is encoding. Your object becomes a compact binary format. Field names disappear, only tag remains. So if you see in encoded version, we do not write the field name. Name, age, and email are completely gone here. We just write a tag name that is 1, 2, and 3 that is encoded in binary format. That way it is easier to map it. So this is called the magic of schema evolution. Now, what if you want to add one more field in this case? You just add one more field. Let's add address for the person. We just add string and person. Now, to maintain the backward compatibility and forward compatibility, we should maintain it as optional, not required. If we move it to required, then it won't be a backward compatible. So that is why we will make it an optional field with string, type, and address. So the old code ignores it and the new code reads it. This is called backward compatible. Another use case of forward compatibility. What if I want to remove the field age? Now, old code expects the value of age and the new code doesn't expect. How do we resolve it? How do we make it forward compatible? Any guesses? We just make a default value for the older field. So if we remove the field we want to remove it, we just set the default value. It can be null. In many cases, we just put the default value as null so that the old code does not break even the new code. This is called forward compatible. So it's easier to change from int32 to int64. Now what if, here's a tricky question. I want to change int32 to type string. In this case, the code breaks. Now, what do we do in this case? Here are some of the rules which we need to follow in case of Protobuf and Thrift. Never change the field tags. The field tags 1, 2, 3, you should never change them. These are like the identity. And never also reuse them in any of the fields which we define. Because these are like primary, never reuse them and never change them. Use optional if you add new field. That will make it backward compatible. Use reserved deleted field that prevents the reuse of the code. Thrift is similar but has 3 encoding formats. First is binary protocol. It is compact and fast. Then another is compact protocol in Thrift. that is even smaller, made it much more compact. And then the third is JSON protocol, which is human readable for debugging. So the Thrift has provided all three variants, which we can use it in public APIs, internal APIs, and everywhere. Here's a real world use case. Uber uses Thrift for all service to service communication. When they add features, old service keep working. Zero downtime deployment. For interview, always mention field tags when discussing about Protobuf. It shows you your understanding on the internals of this architecture. Now, LinkedIn processes 1 trillion messages daily with Avro. It's better than Protobuf for one critical reason that we'll discuss now. Apache Avro is the dark horse of encoding formats. It was created by Duck Cutting, who also created Hadoop. It is designed specifically for big data systems. Now, what makes Avro different? The key difference is it does not have a field tags the way we have in Protobuf. You just assign the field tags manually. In Avro, you don't have field tags. Like in Protobuf, you assign field tags manually. In Avro, you don't. The schema itself identifies the field by name. But wait, doesn't that make it JSON? No. Here's the trick. Avro has two schemas. One is the writer schema and another is the reader schema. And this is used for encoding and decoding. Each one of they have their own version also. So if you see writer schema has a version V1, this writer schema has a version V2. The writer schema V1 is sending name and age, but the reader schema has name, email, and city. How do you decode it? Okay, so in this, the reader schema decoder first sees the version number, and then if there is any extra field, it will assign a default value. This makes it perfect compatibility. The key difference too is dynamic typing. Protobuf requires code generation. Avro doesn't. You can read Avro data without knowing the schema in advance. That's a huge for data lakes. Third difference than Protobuf is schema registry. Avro is designed to work with schema registry. You need to register all the schema versions. Every message, if you see here, has a schema version. Here it is V1, here it is V2, and not the full schema. It is just the version number that is mentioned. So how it works? First, writer encodes the data with schema version V1. This message includes the schema ID and name and age. Then the reader fetches the schema V2 from registry. In registry, it is stored. After fetching the schema, it decodes using its own schema version. So, for example, if this reader has a schema version of V2, it uses its own schema version and also gets the schema version from the registry and then handles the translation. Let's take a real world example. LinkedIn's Kafka uses Avro for all messages. Did you know this? Did you know this Kafka uses Avro as well? So they can evolve schemas independently for 1000 plus services without even coordination. Now let's discuss when to use Avro and when to use Protobuf. If we have big data like pipelines, Hadoop, Spark, and Kafka, schema evolution without code generation, or if we are using data lakes where schema changes frequently, then we should use Avro. What about Protobuf? When we have service to service RPCs, we want strict type safety and code generation is acceptable. In that case, you should use Protobuf. Now, here's an interview tip. How does Avro achieve schema evolution without field tags? The answer should be the writer and reader schemas with automatic translation based on the field names and type. Now, encoding isn't just about formats, it's about how the data flows from one system to another. In a distributed system, data takes three parts. One is through database interaction. This is where the data flows. Then through services, how it flows. Then through message queues. Each has different challenges. Pattern one is data flow through the databases. You write data to the database, then you read it. It's very simple, right? But here's the problem. The code that writes might be a newer version than the code that reads it. Let's take an example. You have deployed a V2 version of your app and it has added email field to the user object. V2 writes user with emails to the database. Now V1 version of your application is still running and it reads the user details. V1 doesn't know about the email and ignores it. It updates the username and then pushes back to the database. What's happening? The email field is lost now. How do we preserve it? So for the solution, we need to preserve the unknown fields when decoding. Keep the fields you don't understand when encoding, write them back. This is why Protobuf and Avro preserve the unknown fields by default. Second pattern is data flow through services. That is called service pattern. In this, service A call service B. There might be different versions in this case. If service A is new, it sends a request to service B that is on older version. Service B doesn't understand the new field added by service A. In this case, the solution is backward compatibility. The new client, that is service A, must work with the old client and use optional field or use default values. So in this case, it should add optional to the new field added because service A has a newer version. Now, what if it's the other way around? Service A is old and service B is new. Now, service B sends the response with the new field, right? In this case, service A doesn't know what this new field means. In this case, the solution is forward compatibility. The new service, that is B, must work with the old client and don't make the new field as required. Don't make it required, add it optional. For the real world example, let's take Netflix. Netflix has around 1000 plus microservices. What happens if it updates one of the field in Optic? It shouldn't break down all the services. The services must handle version mismatch gracefully. Coming to pattern 3 is message passing data flow or message queue pattern. The scenario is service A publishes data to a messaging queue. Okay. Now service B consumes from this queue at the same time or maybe after few hours. After few hours, the service A upgraded the version and added some new fields. Okay. And now what happens with service B? Service B is still on the older version and has some another schema version. What is the solution? In this case, the solution is we should have another schema registry with the version numbers. Service A should mention the version number of the data they are publishing. This way, the consumer can fetch from the registry which version they are sending and then can do the translation. Uber's event bus handles billions of events. Services published with schema version V5, consumers read with V8, and the system handles translations automatically. Now, the key insight from these three patterns which we have discovered is that the challenge here is same. It's called temporal coupling. Data written at time t1 is read at time t2 with different code versions. So your encoding must handle this. For interview, when you're designing systems, always ask what happens during the rolling deployment. This shows you think about the real world operations. Okay, REST is not always the answer. Google uses RPCs, Amazon uses message queues. Let's compare three of the communication patterns in the distributed system. We'll start first with the REST. REST is representational state transfers. This uses HTTP verbs like get, post, put, and delete. It handles resources or identify the resources by the URLs mentioned in it. It is a stateless language and it is human readable, usually in the form of JSON. Some of the benefits of using REST is it is widely used everywhere. It is great for public API and it is cacheable using HTTP caching and it is firewall friendly. The problem with this is it is very verbose. It is slower than binary protocols and it does not support streaming. In HTTP 1.1, it is not supported. Next is RPCs, remote procedure call. You call a remote function like a local function. We have different methods, right? You call each other them. How do you pass the data? That is called a RPC call. If you call from one method to another method or another function or another, we use binary protocols in there. So, like if you see gRPC uses Protobuf, it is very strongly typed. It supports bidirectional streaming. So the benefits is since it is binary encoded, it is very fast. It is type safety. We are maintaining the type of the data in each case, and then it also supports streaming. It is efficient for internal services. The only problem is it is very tightly coupled to the client needs. It is not firewall friendly and it is very hard to debug. Let's take an example. Google uses gRPC for all internal services. That makes it 10x faster than REST and with strong contracts. Now, the third one is messaging queues or async pattern. This primarily uses the PubSub pattern or publisher subscriber pattern. This is very important because it can decouple the sender and the receiver because there is a queue in between sender and receiver. And we can also persist the messages between in the queue The delivery format is at least once or exactly once. Now, the advantage here is it is very decoupled way. It allows buffering. It is very reliable because we can do retry and failure. It can have multiple consumers also from the same messaging queues. The problem with it is very complex. Complex in the sense it needs a complex message broker. It is eventual consistency and it is harder to debug because it is an async flow. We need to debug on all the levels. I'll take an example here. So Amazon uses SQS for order processing. If the payment service is down, the order queues up and processes it later. Now you will ask me here when to use what. When do you use REST, when do you use RPCs, and when you use message queues? If you're using public APIs, CRUD operation, or simple request and response, you use REST. Now, if you're using internal microservices, if performance is very critical, and or if you're streaming data, you should use RPC. Now, for async workflows, event-driven architecture, and decoupling the services, always messaging queues. For interview, we'll ask you design a food delivery system. Which communication pattern do you use? We'll use REST for backend, that is public API, RPCs for backend microservices communication, and then message queues for order processing for reliability. We mix and match based upon the requirement. Now let's recap what you've learned so far. Never use language specific serialization in distributed systems. JSON is great for APIs and binary for internal services. Third is protocol buffers and thrift. They use field tags for evolution. The fourth thing we discussed was about Avro, how it uses reader and writer schemas. There is no tags required in this case. Fifth point we discussed about always preserve the unknown fields during encoding. Then six, we discussed about the design of rolling deployments, versioning, how we will handle the mismatch. And the seventh point we discussed about the differences between REST, RPCs, and message queues. So if you're preparing for FANG or any software engineering interview, you will be asked about the encoding and schema evolution. So practice explaining how Protobuf handles backward compatibility, how to use Avro versus Protobuf, how to design APIs that evolve gracefully. In the next video, we are going to deep dive onto replication and consistency in distributed databases. So subscribe if you don't want to miss it, and drop a comment if you have used any of the encoding format which I haven't covered. I will make sure to make a video about it. Thanks for watching and good luck with your interviews.